Okay, welcome to Mr. Olszewski's lessons on chemical bonding. This is section 1B, electron transfer and the formation of ionic compounds. Okay, so an element can form a compound by transferring electrons to become an ion. So an ion is just an atom with a positive or negative charge because it has an excess of electrons or an excess of protons. Protons are positive, electrons are negative. When the numbers are equal in a neutral atom, there is no charge. If an atom, because we don't gain or lose protons in regular chemistry, that would only be in nuclear type reactions. So the protons remain the same. So if we gain an extra electron, we get a negative charge. We gain two, we get a negative 2 charge, etc. If we lose one electron, then there's one more proton than there are electrons, so you end up with a positive charge, and so forth. Now, when you form these ions, you form a positive ion, opposites attract, will attract a negative ion. And that's how ionic compounds, attract each other, how they're made, how the atoms, positive atoms, or ions I should say, attract the negative ions and they form a chemical bond. Now it gets the name for these types of bonds, the ionic bonds, come from that it's made up of ions. The chemistry is pretty straightforward in a lot of ways. Okay, so when an atom loses an electron, it becomes an ion with a +1 charge. When an atom loses 2 electrons, it becomes an ion with a +2 charge. If it loses 3, +3. If an atom gains an electron, then it has a -1 charge. If it gains 2 electrons, it has a -2 charge, 3 electrons, -3 charge, and so on. Okay, so some important term, ionization energy. It's the energy required to remove an electron from a neutral atom. Right? Everything involves energy. So when we remove an electron from a neutral atom, there's an energy exchange there. We call that ionization energy. Okay, so let's look at an example. You have sodium. If you look at the periodic table, sodium is atomic number 11, which means it has, when neutral, it has 11 electrons and 11 protons. But it only has 1 electron in its outer shell. And the sodium will react by losing that outer shell electron. And in doing so, the sodium atom becomes a sodium ion with a +1 charge. And so we'll represent it with this circle, with the symbol for sodium and a 1 positive sign, indicating it has a +1 charge. Now chlorine, a side note here, sodium is a metal. Metals typically react by losing electrons. Chlorine is a nonmetal. It will react by gaining electrons. Now chlorine in its neutral state has 17 electrons, but only 7 of them are in the outer shell. So chlorine can, remember the octet rule, it wants to get 8, so chlorine typically reacts by gaining 1 electron. And by doing so, it gains a negative charge. So it forms an ion with a -1 charge, and we'll represent that with the green circle with the symbol for chlorine and a 1 negative symbol in there. Now, opposites attract. So positive ions, many positive ions, can react with many negative chlorine ions and attracting each other in a 1-to-1 ratio. And they don't just form one-on-one, they form millions on millions. And the only thing we know for sure when they make this crystal is that the number of sodium atoms is going to be equal to the number of chlorine atoms, or ions equal to ions. That's how ionic compounds are formed. So the ions in most of the ionic compounds are organized into a crystal. In this case, the alternating positive and negative ions in the crystal. By the way, we call the positive ion the cation and the negative ion the anion. So 2 other terms that you need to know. Now these crystals can be used. Here's an example of crystals that you can see through a very inexpensive microscope or even a a magnifying lens. If your eyes are really good, you put some salt in your hand, you can then look at it and see these little tiny crystals. Here's a drawing that represents this crystals. We call this crystal structure a lattice, and notice we have the ions, the positive negative ions, arranged in a nice, neat, orderly arrangement. Here's a cesium chloride ion crystal lattice. Notice they're different. There are many characteristic different shapes for the crystal lattices and arrangement of atoms. Okay, so there are many factors that can affect the ionic bonding. You're starting with, in this case, there's an energy diagram. You're starting with metal and non-metal elements that are sodium is solid, chlorine's a gas. And it takes energy to make gaseous ions out of these. And then that's a two-step process. We're looking at forming the gases and then forming the positive negative ions. And then there's the combining of those negative ions. So let's take a look at this more closely. All right, so you've got the solid sodium forming an ion and the chlorine forming an ion. And then here you've got the sodium and an electron and the chlorine forming. Now that electron goes from the sodium loses it and the chlorine gains it. That's how the sodium becomes a positive charge and the chlorine becomes a negative charge. And each one of these steps represent an energy change. So after you've got these separate positive and negative ions, when they come together, all right, everything so far, well, these initial steps have cost energy. You have to put energy in. When these positive and negative ions come together here, then you have a decrease in energy. So the whole point is that the sodium chloride lattice structure is a lower energy than the individual ions were. And that's what this graph illustrates. Okay, so it takes energy to convert the elements to the ions. It takes energy to create a cation. That's an endothermic reaction. Energy is released when you make an anion. That's an exothermic reaction. And the formation of the solid releases a huge amount of energy. This is also an exothermic reaction. And this makes the overall formation of the salts from the elements exothermic. We're going to show you later on how to calculate energy of bonds and a total energy of reaction, or an enthalpy of reaction, as we like to say. Okay, so this huge exothermic transition is the reverse of lattice energy. What is lattice energy? It's the energy required to completely separate a mole of a solid ionic compound into its gaseous ions. All right, so interesting. The energy it takes to separate them is the same as the energy that's holding them together. And we call this a lattice energy. And this, the energy associated with this electrostatic attraction can be governed by Coulomb's law. All right, so the energy is equal to Coulomb's constant times charge 1 times charge 2 over the distance. Okay, so here's a chart of different lattice energies. Notice something here. Look at the pattern. There's an increased charge on the ions. So the lattice energy will increase as the charge on the ions increase. And it'll decrease as the size of the ions decrease. Okay, so that is the end of section 1B.